Hi, here's our last couple of examples in this section. So one example of a situation where you have slope is in the form of a literal slope on a ramp. And there are regulations about what the slope of it can be. The slope must be less than 0.24. And suppose you're a construction engineer and you have some kind of height you've got to get up to here, and you know that that height is 4 feet there. You want to know how far do we need to go horizontally. Well, that horizontal distance is usually what we call delta x. And let's write a sentence, both in English and as an equation, that says the slope is 0.24. So to turn this into an equation, the slope is what we call delta y over delta x, but we know the delta y has to be 4 feet, so we're going to write that as 4 divided by delta x, and the is turns into equals, because that's what equals means, and that must be 0.24, and then there's a 0.24. Didn't have to do much with that. Now let's solve this equation for delta x. This is a little tricky because it's in the denominator, but what we can do to get rid of that is just multiply both sides by delta x. Because on the left side, the delta x multiplied by 4 and then divided by delta x, those cancel each other out. So you just get a result of 4 equals 0.24 delta x. And then from there you can divide both sides by 0.24. Here's my calculator app to do 4 divided by 0.24. That comes out to be 16.666, 16 2/3. Let's write that as 16.67, sounds like enough precision, rounding off there. So whenever you have a word problem like this that's asking you something about the real world, you shouldn't just write your answer like that. You should actually say what it means. The ramp will need 16.67 feet. You should always include units with word problems for the answers. And that is an answer right there. Now, I want to mention a really important fact about linear equations is that they always have constant slope. That means it's always the same between any 2 points. So it doesn't matter which 2 points you use. Just to demonstrate that really quick, here's an equation. Here's a graph of y equals 10 minus 3x. We can look at the slope from this point down here. That's a horizontal change, a delta x of 1, a vertical change of -3. And if you do -3 divided by 1, that result is just -3. And the same thing is true if you do it with each of these. I could go down -3. Now, it's also true if you go further. So if I was going to, I don't know, maybe start at this point and go over this far, like so, that gives you a horizontal change from going from 0 to 3 of 3, and a vertical change going from 10 down to 1. That vertical change is -9. So negative 9 over 3 is still negative 3. Now, you can use that to determine if points are on a line or not, because if they are on a line, they should certainly have constant slope between any points. So here's an example of how you could do that. If we have these points, the t is going to represent the input, the x, and the p represents output. We want to see, could this represent a linear equation? And if the points have constant slope between all of them, then they could be a linear equation. So let's look at the calculating some slopes here. So between the first points here, you have a delta t of 5 and a delta p of 3. So that delta p over delta t is going to be 3 over 5. And by the way, just as a reminder, you could always get each of these things by subtracting. I mean, I just looked at it, but you could say that 3 is 3 minus 0, and the 5 is 10 minus 5. That works just as well for that one. Now let's look at between these other points here. Excuse me, I made a little editing mistake there. Anyways, the delta p there is still from 3 to 6. You can still do that as 6 minus 3, and then 15 minus 10 for the delta t. That still gives you 3 over 5, which is the same as it was before. Let's keep going. Between these points, we have a delta p and a delta t of going from 6 to 12. That gives you a change of 6. So we can write this as 6 over 5. Oh, wait, that's not the same thing as 3 over 5. So because these are different, and by the way, if you were to do this one here, you'd get 12 to 24 is 12 over 5. That's different again. So these are totally different numbers, which means it cannot be a linear equation. This is a pretty long section. There's some important, pretty deep ideas in here. I hope you're getting help if you need it, and working on as much as you can on your own, and I'll see you in class.